Alright, so we're going to look at types of error. This links back to what we're talking about with precision and accuracy. What's the difference between precision and accuracy? What do we know? Mason, what do you understand accuracy to be?
I don't know. Target?
Yeah, whether you're aiming at the right value. Okay, so whether you're shooting for the right value. So whether your experiment is able to hit the true value. What's precision, Lockie?
When it's all in the same place.
Yeah, so how far away your measurements are from each other, correct? So we've got two types of error we're going to deal with. They come under different names, but I like to use these two names because they make the most sense. We have random error. Random error is a lack of precision. So again, random error is a lack of precision. So that is, as an example, when you're using a stopwatch to time a mousetrap racer or something like that, there is a fair bit of random error in that. There is also some systematic error, but there's random error in that. Why is there random error in that?
Because you know you wouldn't be able to stop the stopwatch exactly.
Yeah. You're not going to exactly get the stopwatch correct. You might react a little bit late, all sorts of things like that. You might preemptively go early because you're trying to guess when it hits the line, that sort of thing. Other things could be like when we're doing drop height on a ball, what part of the ball hits the ground, that sort of thing. Does that make sense?
The bottom of the ball.
Yeah, but like, does it hit the seam? Does it hit the, you know? Make sense? You could look at the quality of the ball, all sorts of things like that. They're random errors, they're lack of precision. So when we're using equipment that doesn't have precision, so for example,
Attention staff and students, sorry for the interruption. Could I please have Tani Davison to report to student reception? That's Tani Davison. Could you make your way down to student reception immediately? Thank you.
So when you're doing that drop height experiment, another example of some random error might be using a meter ruler, which only has meter intervals on it. That's not going to be super precise. Why not?
Because it only shows a meter.
Yeah, you're guessing between the meter and the half meter, that sort of thing. So either be above or below the true value. The meter example is obviously pretty ridiculous because we'd never do that. How can we fix up errors of precision? What's the best way to fix up an error of precision?
Do it again.
Liam speaks wisdom. Do it again, and again, and again. So repeated trials and average. Very good. So that is a random error. A systematic error is an error with our system. It prevents us from finding accurate results. It will either be consistently above or consistently below the actual value. So Brendan's been going to the gym, he's been doing some I don't know what they were doing, but they were doing clean and jerks, whatever you want to call it, I don't know. They're doing, anyway, Liam's doing his butterfly pull-up from CrossFit, whatever you want to. Anyway, both the lads, they're pretty impressed with their performances. They want to go and jump on the scales and see how they've been going, right? See if it's been paying off all this work. So they jump on, before they jump on the scales, they see 5 kilos on it though. And they jump on, ooh, 5 kilos of muscle this month. Yes. Are they correct or not?
No.
Why not?
Because it's already 5 kilos.
Already 5 kilos. So that's what we call. They need to calibrate the scales to put it back to zero. Okay. Bailey's becoming a Mercy Runners. He jumps on the scale, says he's gained 3 kilos. He's disappointed. He's been doing all this running. He's still gained 3 kilos. What's actually happened?
Put muscle on.
The scales are out. The scales are out. He's lost 2 kilos. Okay. We can fix these errors with calibration. Okay, so all we have to do is take our measurement and scale it back to 5. That type of error is called a zero error, and that is a systematic error, and it can be fixed with calibration. That's all well and good. It's easy to calibrate when we know what we're shooting at, very hard when we don't. So it's easy to calibrate our scales because when we see them lying there, we can see, oh, it's starting on 5, we need to scale it back to 0. Does that make sense? When we're doing things with electron microscopes or various other things, it can be a lot harder to calibrate. So systematic errors are errors of accuracy. We can calibrate that random errors when we're not using the right equipment and we're not precise enough. We can fix it with repeated trials. The best way to fix it is to use the best equipment available. Clear? So they're the two types of errors. You're now going to jump onto Education Perfect and pump through some of those.